Almost every piece of metal we use in our daily lives is an alloy, whether it's the wheels of our cars, the cutlery we eat with, or even the jewellery we wear. But what are alloys and how are they made? Alloys are essentially mixtures of a base metal and one or more additional elements. Combining metals like this produces a material with very different properties to the individual metals on their own. And this technology isn't new. In fact, humans have been making and using alloys for thousands of years. The very earliest example is bronze, an alloy of copper and tin that started being produced around 5,000 years ago. Adding tin to the copper reduces the melting point and results in a stronger, harder product that's easier to cast and is better for turning into tools and weapons than copper on its own. After its discovery, the benefits of bronze meant that its use was so widely adopted that it gave its name to that era of human history, the Bronze Age. Another example of an alloy is solder, a low melting point alloy of lead and tin that's used to connect components on electronic circuit boards and to join copper pipes together around the house. And where strength is a priority, steel, which is a mixture of iron and carbon with trace amounts of a few other metals, is hard to beat. Alloying can also prevent metals from corroding. Stainless steel, which is made by mixing steel and chromium, is protected from corrosion by a thin layer of chromium oxide that forms on the surface. And because it won't rust, it can be used for anything from cutlery to car parts. Another important use of alloys today is in turbine blades for the jet engines that power the aeroplanes that take us on holiday. Nickel-aluminium alloys have been used for this purpose since Frank Whittle's earliest designs in the 1940s, because nickel is light and has a high melting point, meaning it can withstand the high temperatures inside the engine. The added aluminium also makes the alloy lighter and stronger.
Aluminum-lithium alloys. Key facts. 1. Lithium, the world's lightest metal, decreases the weight of aluminum while improving its strength, toughness, corrosion resistance and forming characteristics of the alloy. 2. An advanced structural alloy comprised primarily of aluminum and lithium with traces of copper, zinc, manganese, magnesium, zirconium, iron. 3. An important material characteristic of the modern alloy is the fatigue crack growth, FCG, performance. This allows aircraft designers to use less material for the same level of safety margins. Physical properties. 1. Sheet. 2. Bar. 3. Powder. Aluminum lithium alloy, Ali, powder, spherical, with a maximum lithium content of 3%.
For watching. Hope you like it by Jerwin Ahina.